Hi, and welcome to the Power Hungry Podcast. I'm Robert Bryce. I'm the host, and this is a podcast where we talk about energy, power, innovation, and politics. And my guest today is Rod Adams. He is the publisher of Atomic Insights. He is also the host of another podcast, the Atomic Show podcast. Rod Adams, welcome. Thanks for being on the show.
Thanks for having me, Robert.
So we're going to talk today about, I've specifically invited Rod because of his long experience in the nuclear industry and the atomic sector. I want to handicap the many different technologies that are out there. And that's the focus of going to be the focus of our discussion. But Rod, as you've listened, I believe, to my podcast, I have guests introduce themselves. So I've already given a little tease about your background, but if you don't mind, give us a short introduction to you. Assuming you've just walked into the dinner party and you don't know anyone there, introduce yourself, please.
Sure. My name is Rod Adams. I'm a Navy nuke, a ring knocker. I've been a podcaster for 15 years and a blogger for 25.
Sorry, ring knocker. I have to interrupt. What is
a
that
ring
mean?
knocker? Yeah, I graduated from the Naval Academy.
Okay. Well, see, now I don't know that term. So, okay, got it. Okay. All right. But ring knocker doesn't, if anyone else in podcast land knows that means Naval Academy, then, speak up.
But, well, it pretty much means any service academy because we all graduate with big rings on our fingers. And,
okay.
Got it. The reserve officers generally, call us in a derogatory term, ring knocker, but I proudly wear the term.
Okay. Got it. I'm sorry. So, a nuclear Navy veteran, a ring knocker, and then I'm sorry, I interrupted you.
No
Please
problem.
Continue.
Not a problem. A 25-year blogger and a 15-year podcaster on the topic of atomic energy. Like to talk about atomic energy from a political, historical, economic, technological. I mean, it's a fascinating topic to me, so I'm ready to roll.
So why is it, well, I want to get into the handicapping because there are many obstacles to deploying new nuclear, both here in the U.S. and around the world. But why are you so passionate about it? What is it that has made it this passion of yours for so long?
Well, unlike many nuclear advocates, I have no conversion story to tell. I became pro-nuclear about the age of 8 when my father came home from work one day and said, "Hey, Rod, my company's building some new power plants that don't even have smokestacks." And he knew that I didn't like smokestacks very well. And we've been talking about power plants already because he was a electrical engineer for the utility company and is one of those kind of 1950s vintage dads who bring work home and talk about it around the dinner table.
Uh-huh. And so, and you're a former, if you don't mind, just a quick history. You were an engineering officer on the USS von Steuben, which has now been retired, but it was a nuclear submarine. Tell me about that.
Yes, I served on 2 nuclear submarines, the SSBN 634, which is a Stonewall Jackson, and then my second tour as engineer was the SSBN 632, the USS von Steuben. 2 of the 41 for Freedom boomers, both at S5W reactor plants, and they were essentially identical. Small manufactured nuclear reactors built in shipyards in a series production in the 1960s. 1961 for one of them and 1962 for the other. Back then we built, I think, 40 ships in 8 years, all with the same power plant.
Which is remarkable now because we're building, when it comes to nuclear plants, and I just want to get this out of the way. So it's generally, I refer to as nuclear energy, but your shows, you use atomic. That's your predilection? Was there a story behind that?
Atomic is sort of a throwback. That's what people called it when it was first introduced to the world. And the initial energy source was called atomic energy. And that's what all the popular eras of the 1950s, the books were talking about atomic energy. It was called the atomic era. And it seems to have a much better connotation for people because people use atomic in brand names for things like Red Hots that you put in your mouth,
right,
for skis, for tattoos.
Sure.
People like atomic. It's a word that doesn't carry the the negative connotations of nuclear, and also with the last name of Adams. I like atomic because there's some alliteration there. And as a matter of fact, atoms and atoms sound a lot alike.
Okay, got it now. Stand by just one second. I'm going to hit pause here. Okay, so well, thank you. Atomic and atoms, atoms and atoms. So let's jump right into it because I've had guests on the podcast before to talk about atomic energy, nuclear energy, and some of them were reluctant to handicap the technologies that may emerge as the winners. And you've had long experience in this, now decades of experience, and we talked about it over the phone the other day. But if you don't mind, I had the Carolyn Cochran from Oklo on the show. They're developing a very small reactor. Of course, the AP1000 is out and being deployed at 1,000 megawatts. What reactor technology? What types of reactors, in your view, are the ones that are likely to succeed, or what do they call it, the research and development valley of death, and actually be deployed?
Well, I have to be honest straight. First of all, I'm a fission fan. And so pretty much any reactor that uses fission, I'm interested in and like to take a look at and believe it has a fundamental advantage over competitive energy sources, because atomic fission is well known, well understood, and extremely concentrated. As I like to tell people, a fuel pellet the size of my pinky contains as much energy as a ton of coal, 147 gallons of oil, or 17,000 cubic feet of natural gas. And that's with the current method of using it. Once through light water reactors with low enriched uranium. If we were to fission that entire pellet, multiply all those numbers by 20. Because right now we only use about 5% of the potential energy in a fission in a fuel pellet. So you say, which ones do the AP1000 has got a lot of strengths. They finally have a complete design, which they didn't have when they started building it. And that's one of the disadvantages that the Vogtle, or one of the sources of the problem that Vogtle has had, was that when they started building.
And just to interrupt, we're talking about Plant Vogtle in Georgia.
Right, Plant Vogtle in Georgia.
Which is being developed by Southern Company, and that project now is many years over schedule and many billions of dollars over budget. I don't know how many billions, but yes, it's taken a long time. And just one last point, AP1000 is a Westinghouse design.
Right, AP1000 is a Westinghouse design. It was actually, the construction started in 2012. It was originally supposed to be completed, the first unit in 2017 and the second unit in 2018. But there was some real challenges associated with, I've got a whole section on my blog called the Ap1000 Saga, and there's a whole series of things that were wrong. And one of the biggest problems was that the design was certified by the Nuclear Regulatory Commission, but it really wasn't a detailed construction design that was certified. It was, the design that gets certified by the regulator is more of a concept, not a conceptual design. It's not something you can build on. It's sort of like an architectural drawing that you want to choose for your house, but nobody's actually drawn in where the windows are, where the wires go, where the plumbing is, what the measurements are.
It's not the final blueprint.
It's not a blueprint. It's not something you can build off of. And so when they started building those plants, something like 30 to 40% of the blueprints were complete. And they've had a lot of problems because the design wasn't complete. They've also had some challenges because it was the first nuclear plant that we started building in the US since the Nuclear Regulatory Commission was formed. They had never actually licensed a plant that got built, even though they were split off from the Atomic Energy Commission in 1974. Not a single
So
plant.
just to so even here in Texas, I live in Austin, and the city owns part of the South Texas project. You're saying that the design for the South Texas project was approved back in the 70s before the NRC before it became the NRC.
It was submitted to the Atomic Energy Commission sometime before the NRC became the NRC.
Wow. Okay. So I didn't realize that. Okay.
The
So
NRC may have actually finished the job of licensing. There was some licenses that were completed, but they
right.
were all submitted before 1973.
On reactor designs that then were carried on then
Sure.
and built for decades. Yeah.
Right. And I think that the last NRC license got issued sometime in 1986, maybe, but those licenses were all submitted before 73. It took a long time. I mean, the NRC, after 3 Mile Island, the NRC had a 4 or 5 year hiatus where they didn't approve anything. They were trying to figure out what they needed to do to recover from that.
So just to get back to then, so that history is important and relevant. But if there were, if you don't mind, go through then the three or four different reactors that you think are the handicap them and say, well,
Okay.
of the ones that are now being developed, and I of course don't want to ignore the Chinese and the Russians here because they're still building reactors at a pretty remarkable clip.
Yep. Yeah. If I was a utility executive in either Duke, NextEra, or Southern Company, my next reactor would be an AP1000, and it would be sited at one of the 3 plant sites that already have complete construction and operating licenses on the shelf. At Turkey Point, at William States Lee, and at Plant Levy in Florida. All 3 of those plants already have approval to start construction whenever they're ready to pull it off the shelf. And the AP1000 is a big plant that is finally got a complete design, and most importantly, it's got a workforce that is just finished building or just about to finish building one. So if you want to hire people that know exactly how to pour base mat, how to erect the shield buildings, how to do all the things you need to do, I would put in a contract very soon before those guys go off and find something else to do with their life.
But how likely is that to happen?
I don't know. I listen to a lot of utility executives, talk to them a lot. None of them are willing to say they're going to do that. All of them are waiting to see the final operating plants at Vogtle. They're close. They're going to be starting up in 2021 and 2022, but they still haven't started yet. There's still a few things left that the skeptical show me executives say, I'm not quite sure that I'm ready to go. And of course, there's still people that believe that it's just as easy to provide the power they need by buying natural gas. And that's getting harder and harder. I mean, some of the places that were planning on burning natural gas in the Southeast are finding out now that the pipelines that are supposed to deliver it have all been stopped.
So that
2
would be
pipelines.
The Atlantic Coast Pipeline was just stopped, right? And that would have figured into Duke's plans. But Duke is going ahead with more gas plants in Carolina, aren't they?
Well,
potentially.
If they can get gas for them, yeah.
So that you bring up a point there. Well, okay, so that's the AP1000, and so you said if we were going to build one, and that's a big plant.
Mm-hmm.
And I want to come back to the issue of size because that matters, and about what are the building blocks that make sense in today's marketplace, where it seems like the size of the generation units is going down. Okay, sure. So you've talked about AP1000. Now give me,
now remember, those 3 COLs are all in the Southeast U.S., all in a place where there's a big dependence on gas and not a lot of gas supply. We're not in the Marcellus Shale. We're not next to the Permian Basin. So the gas supply here is not as robust as it is in many places. And it's a place where the population is growing pretty fast, especially in Florida. We're getting 1,000 new residents a day down here. So we are going to need some power in the near future, and a big plant would be okay. Again,
Right.
so when you say the market really is different depending on where you are. There isn't a market for large nuclear plants in the Northeast. Population is fairly stable. They're not very friendly to nuclear. I wouldn't try building a new nuclear plant in the Northeast. Best I could hope for in the Northeast is to keep the few that are there still running.
Right.
In terms of new plants, I'm excited about some really innovative technology in small light water reactors. The NuScale project is fascinating to me. These are integrated light water reactors that are natural circulation, which means that they don't need electricity to drive cooling pumps no matter what happens. And they have been able to prove to the Nuclear Regulatory Commission that their reactors will not need external sources of electricity or water no matter what happens. The plants can go through a whole bunch of different things, and they will shut down and keep themselves cool and from releasing fission products indefinitely.
So
without any electricity.
that's the passive safety.
Passive safety.
Attribute. Yeah.
Yeah. And so those plants are interesting. And another thing that's really fascinating about NuScale is just yesterday, I got a press release that said by doing some more detailed analysis and modeling, the NuScale company now believes that the reactor that they originally thought was going to be a 50 megawatt reactor, later upgraded to 60 megawatts, is now going to be 77 megawatts without really changing any capital expenditures.
So they've uprated it before they built it.
That's right. And on a cost per kilowatt capacity basis, that drives down the cost.
Sure.
So
NuScale's argument or their value proposition, the way they're selling that reactor is, okay, you don't need 1,000 megawatts. You can start with 77, and then you can add those increments in what is it, a 12 pack? That's one of their. Is that their? It's been a while since I've looked at NuScale.
The 12 pack is what they want, what they've been marketing initially, and the main reason they've been marketing the 12 pack as their starting point is that they know they really need to have an order book of roughly 40 units of these modular reactors to really pay for the investment in infrastructure to build them.
I see.
You're going to have to build the factories and get the forgings and all of those things to get these modulars coming out on a repetitive basis. And that takes an investment. So they knew they needed an order book. So they figured if they're selling them 12 at a time, they didn't need to make too many sales.
I see.
So
that first of a kind is very expensive, but once you start cranking them out like anything else, that cost per unit goes down.
Yeah, and I learned the first of a kind issue and the value of series production firsthand. I spent 3 years running a small factory, and I'd have people come in, and we did some custom injection molding for people as well as our line of products. And they come in with a fancy new part, and they'd say, "Hey, Rod, how much does it cost to build this?" I'd say, "How many do you want?"
Right.
They say, "I want one." I say, "Well, that one's going to cost you $40,000. It's just a small plastic part." I said, "Yeah, but I got to make a mold."
Right.
So, it takes time. It takes an investment, and then you got to spread that investment over enough units. And a number of units you produce every year really drives down the overhead costs of operating a factory.
Sure. And so you mentioned
You also get learning curves.
So right. So and the learning curve is important. So you mentioned Ap1000, and that would be a viable option. And we're talking geography here, because geography always is. I've written it determines largely fuel. Right. They're intimately connected. Hydro works in the Pacific Northwest and a few other places. Doesn't work in West Texas. So,
right. And wind doesn't work in the Southeast.
And wind doesn't work in the Southeast. And solar, according to a friend of mine who works in Florida, he says, well, we get a lot of cloudy days, so it's not ideal for solar either.
Right.
So a large increment of new nuclear would be viable in Florida. Then where do you see the opportunity then for new scale? Is that island economies? Is it? I know that they have one of the other things that I think works in new scale's favor is they have a location at the Idaho National Labs and they have a customer already, right? So they
Right.
have a fair amount of momentum behind
Hmm.
them with UAMPS and which is the a utility. Well, I guess it's a collection of utilities.
Utah, yeah, Utah Associated
Association of Municipal.
Municipal Power Systems, something
Yes,
like that.
exactly. So they have a location. They have a federal loan guarantee. They're a federal grant, right? Of
Right. They're going to get
$500 million.
$1.4 billion over a 10-year period
Right. So
to help them.
that gives them a lot of momentum. So, so if after Idaho, where might the new scale fit in this geography in terms of need for new nuclear?
Well, NuScale is the recent press release also not only upgraded the plant, but it said that they're now offering two more size options: a 4-unit plant, a 6-unit plant, a 12-unit plant. Now, with a 4-unit, 77 megawatts per unit capacity plant, now you're talking about something that is what, 350 megawatts or so,
Right.
which actually fits rather nicely onto uh, plant sites that currently host old coal facilities. So we're moving away from coal in the US, and a lot of places where we need to replace coal, there aren't any natural gas pipelines, because why would anybody build a natural gas pipeline into a coal country, into Indiana or Kentucky? They just aren't there. So, I mean, natural gas is readily available in some places, but gas has to be piped to other places. And
Sure.
if there's no pipelines, that's a really high burden to get pipelines to go in. It's not just the fact that they don't exist, but siting them is a problem. You got to get permission of every landholder along the way. And there's a big push right now to stop making major capital investments in gas infrastructure because people think it may be stranded if we're trying to move away from
Sure.
carbon emitting fuel. So I think NuScale, the size of that reactor, the roughly 350 megawatts, and we're going to come back to that a little bit later in the handicapping, is a good size to go and replace decommissioned coal plants,
Well,
and
that's an
also
interesting.
to go into places where there's slow growth in the market, and the utility says, "Yeah, I'd like to buy, go to a non-emitting power source, but I don't want to buy them in 1,000 megawatt increments because that's too lumpy.
Right.
My growth is a couple hundred megawatts a year, and if I have to build 1,000 megawatt plants, that's 5 years worth of growth. Do I wait till I have it already necessary, or do I start and have an excess for a while?
Right.
That's too lumpy."
Well, I just want to make a quick comment on that coal location, the coal plants, because I think it's important that we keep in mind that why that makes it an attractive possibility of switching the generation unit is that you have the transmission in place. And
Yep.
that's the other, you've talked about pipelines and the difficulty of siting new pipelines. The exact same thing exists with high voltage transmission, and it might be even worse in siting high voltage transmission. So, which is, I think, one of the key constraints, clear constraints on the development of new renewables.
Right. And part of the NuScale reactor also fits into coal sites because of this passive safety it has. The boundary and the evacuation planning area for the NuScale plant is shrunk basically to the plant boundary, rather than having to plan for evacuations for a 10-mile radius from the plant, which was the old standard.
Right.
The passive safety allows them to drive that evacuation planning, emergency planning zone down to the site boundary.
Oh, that's a good point.
And it's not just NuScale. That's one of the other things that modern smaller reactor designs are trying to do, is drive the planning zones down to a much smaller area and make it so you can put these plants closer to your customers which also allows for beneficial use of the waste heat that comes off of a steam plant. The steam plants are typically about 33% efficient, which means you're throwing away 2/3 of the heat in a low temperature and kind of low temperature non-usable environment. But if you're close to a load, you're close to a city, you'll be able to use that heat for district heating or desalination or something like that.
Gotcha. Okay.
Okay, so
AP1000 by Westinghouse, the new scale. I don't know the name of the model name on their reactor.
It's just called the new scale power module.
New scale power module. And then, so give me a couple more. And what
another one is, it's a fairly recent but leaped ahead entry into this race, is the General Electric Hitachi GEH BWR X300. And the X in that name stands for 10th generation, which means it's a very refined and well-known technology. And the team of GEH has addressed this idea of design to cost. They know what the competition needs and what they need to do to compete against the market. So they believe they can design a 300 megawatt passively safe boiling water reactor using all the things they already know and all the technologies they already have and all their infrastructure to build steam plants and all that thing. They believe they can come to a capital cost around $2,500 a megawatt. I mean, $2,500 per kilowatt of capacity, which when you run the numbers turns out to be a levelized cost number that's very attractive. Somewhere, depending on financing, somewhere in the $40 per megawatt range, per megawatt hour.
Which is a little higher than wholesale prices in the U.S. right now, but it's in the neighborhood. Well, depending on the state, of course.
Well, it's higher than the wholesale prices you get during the cheap periods. There are times when $40 a megawatt hour is very competitive and very profitable when power demand is a little bit higher and the competition is a little minimal. So sure, they can always produce that power. Their costs are level. They're not vulnerable to fuel price changes, or right, they can run whether the wind is blowing, whether the sun is shining. So,
and the boiling water, and when we talked about this before, Rod, you mentioned, and my guest today, just a reminder, Rod Adams, who's the publisher of atomicinsights.com and the host of the Atomic Show podcast, and he's on Twitter @AtomicRod. The boiling water reactor, you mentioned when we were talking the other day, that one of the advantages there is you don't have a pressure system. That is, and that's one of the other safety attributes. Or have I gotten that correct?
Boiling water reactor. I mean, about 1/3 of the reactors in the U.S. are boiling water reactors, and General Electric has always favored the boiling water over the pressurized water reactor. And the big difference is it's a much simpler design because it doesn't have two separate loops. It doesn't have a primary loop where the heat goes through a boiler, a separate boiler, and then goes to a steam system. The boiler in a boiling water reactor is the reactor itself, and there is no steam generators. So it simplifies the system, reduces the number of components. Now there's a cost to that, and that means that the steam that flows through your steam plant has some radioactive isotopes in it. And so you have to control your whole steam plant as a radioactive control zone, and you have to fix it and it's adds some costs, but there's some benefits. And historically, they pretty much come out to be about a wash, the cost between boilers and pressurized water reactors. But with a very experienced constructor, and they're using principles that they have already got licensed from the NRC for a much larger version called the ESBWR. It's got a design certification, but only 2 customers ever said they wanted one. So General Electric never really set up the process for selling them.
Well, if I can
There are
interrupt there
two.
for just a minute, it was because one of the things that's interesting, I just started reading this book, Lights Out, that came out in July about the history of General Electric. And we mentioned Westinghouse already. I mean, just a quick step back. So Westinghouse is now, that name is owned by a Canadian venture capital firm, right? That
Yep,
which
Brookfield
Brookfield Partners or
Development or
something
something.
like that,
Yeah.
which is a remarkable ending for the name of one of the greatest American industrialists. I mean, and the biographies of Westinghouse, he's quite an admirable man and a great inventor.
Well,
And
Westinghouse ceased to be an American-owned company in somewhere in the 1990s. It was purchased at first by British Nuclear Fuels Corporation, BNFL,
uh-huh.
and after about 10 years, BNFL sold it to Toshiba of Japan, and then Toshiba, after it went bankrupt, sold the parts to this Canadian investment company, Brookfield Partners.
Right. So Westinghouse is a shell of what it was, and General Electric is facing a lot of troubles. I mean, just as a industrial conglomerate and looking at selling off big parts of itself just to stay solvent. So I just thought I'd interject that because it's
well, General Electric back in the Jeff Immelt era was ready to sell off its nuclear division completely. It really wanted to exit nuclear. It was focusing on not only its aircraft engines and its gas turbine division, and it started to produce a lot of gas drilling equipment, gas well drilling equipment. It makes some of the best drill bits in the world. They also ended up getting really big into the capital markets because as a big industrial conglomerate, they could borrow at low rates. And I think at one point, more than 2/3 of General Electric's revenue came out of their banking.
right. The
sector.
GE capital arm. Right. Yeah. And then they bought part of Baker Hughes in the oil field services business. And then of course they bought Enron Wind and went into the wind business. I mean, it's an enormous company.
But right now they are consolidating back and they're going back to their power generation roots is one of the things they really want to focus on. Their gas turbine business, and I think they're really going to pay attention to their nuclear business. General Electric is a partner in one of the advanced reactor demonstration projects, which we can get to next.
Sure.
So
just to back up, so we've gone through the GE, the Westinghouse Ap1000. We've talked about NuScale and their NuScale power module, which is 70 some megawatts. And now we're talking about the 300 megawatt GE Hitachi design, the BWR X300.
Right.
So what about the smaller versions? What about the other companies, the upstarts that would be more similar to NuScale's vintage, Terrestrial, Oklo, some of the other companies? Then who do you handicap those companies for me? Who do you think has the best product or in that field?
Yeah, I'm a huge Oklo fan. I think that they're an amazing story. Really, probably the only true bootstrap startup in the nuclear field that's making huge progress. Started by a couple of engineers who met each other at MIT, and they really developed a very strong affinity for finding a way to build a new nuclear plant that checks a lot of boxes. Caroline and Jake ended up getting married and they run the company together, but they've got a small team, very focused
it's a
engineers.
Very small company, what, 30 some odd people? And
it's in their headcounts. Up until very recently, it was in the 20 range, but they're adding a lot because they have submitted this small team put together a license application, a combined construction operating license. In a brief period of time, they test drove it through the NRC, so they already had, got a lot of issues out of the way before they even submitted their application. They were doing this on a test basis, again, bootstrap, small team. Their license application for their 1.5 megawatt electric Aurora power station, powerhouse, beautiful little A-frame, looks very unnuclear to most people.
Right.
but that COL is a 500-page document. And in comparison, NuScale's application for a design certification, which is not even as complete as, I mean, it doesn't give you permission to build anything like a COL does, but their application for a design certification was 15,000 pages long.
30x
Yeah,
larger.
so huge difference. And part of it is they chose a very small power output, very stress-free plants. The plant's under very little stress. It produces its power by heating up and extracting its heat through heat pipes that then have a system that uses supercritical CO2 to extract the heat and turn it into electricity. Um, all kinds of reasons why it's very safe, very passive, has a big shield around it. They can probably put it almost anywhere, and low operating requirements, maybe remote monitoring.
But that's tiny. Just to jump in here, 1.5 megawatts. I mean, you can buy from Cummins, Caterpillar, Detroit Diesel. I mean, there are a lot of vendors out there who sell you a reciprocating engine.
Oh, sure.
Running diesel that'll easily produce 1.5 megawatts.
Yep.
And so
but,
that's a very small.
But if you take that 1.5 megawatt diesel and you put it up in the north of Canada or someplace in Alaska, you have to deliver fuel to it.
Sure. Or
an
island economy or somewhere that's
well,
remote. Yeah.
Islands not quite as hard, because if most islands, if they have a port, it's not that hard to put fuel on a ship and take it somewhere. But it does add a lot of cost. Shipping small quantities of fuel to Jamaica or Bermuda does add a lot of cost.
Sure.
But carrying diesel fuel to the far north is a real expense. And there are mines. There's some really good natural resources up there that need infrastructure to be able to get it out. So that's where they're looking to market. They'll tell you that they have kind of their 1.5 megawatt is their Tesla Roadster.
Right.
It's
yeah.
the early adopters, the people that really, really want or need power, and this is the best available option for them. They really want it to be clean or emission free, for whatever reason. But that's their entry in the market. They're already working on bigger or better systems in addition to that one.
And a military base would be another option for them as well, right?
You
be
bet.
a reasonable size and secure location. And also have to mention Carolyn Cochran's from Tulsa, my hometown, right? So went to the University of Oklahoma. So did my mom. So yeah. But okay. So Oklo, the other company that I hear a fair amount about, and I'm interrupting here, but is Terrestrial Energy out of Canada, that have a molten salt reactor of about 40 megawatts.
I think Terrestrial Energy is bigger than that.
Oh, I'm sorry. Okay, go ahead. Well,
I think the Terrestrial Energy standard is closer to a per module, somewhere in the 200 megawatt range.
All right, fair enough.
Per module, and then they also they think that a multi-unit site is the best economics for them. And by the way, multi-unit is best even for the AP1000 size. It's always cheaper per unit capacity to build 2,000 megawatt plants than to build 1,000 megawatt plant one place and 1,000 megawatt plant another place, because you have a lot of commonalities and learning that happens when you build the second one.
Gotcha.
But going back to Terrestrial Energy is a very well organized company. They've got some really sharp people. They've got they're going through the vendor design review process in Canada to cite their first one at the AECL or Chalk River Laboratories.
And in Canada.
In Canada.
Right.
And they're also taking advantage of there's been a lot of coordination between particularly the US, the UK, and Canada. The regulatory bodies all have the desire to try to learn as much from each other as possible and share as much as they can to speed the process of licensing designs that are going to be built in all three locations.
And
So,
terrestrial, if correct me if I'm wrong here, Rod, but they located in Canada, they domiciled in Canada because they saw a faster pathway to licensing there than they did in the United States.
well, that may be one of the reasons, but another reason is many of their key people are Canadian.
Okay.
So being a Canadian company, it's pretty logical for Ken
Sure.
and Brian and David LeBlanc to want to be domiciled in Canada because that's where they live.
Sure. Okay.
So that they do have a U.S. arm as well. I mean,
Sure.
There is a Terrestrial Energy USA, and they're making progress now. Molten Salt has a lot of real attractions for people.
And this is a departure from all the reactors we've talked about so far. So
right.
Ap1000 is light water. The BWR reactor.
It's a light water reactor.
That light water reactor.
And NuScale is a light water reactor.
And NuScale is light water, whereas Oklo is, well, I hesitate to even describe it. How do you describe that chemistry?
Well, Oklo has some liquid. I mean, liquid metal is inside the heat pipes. And that's what the actual driving material inside the heat pipe that moves heat from one place to another is, I believe, a potassium alloy in theirs, or maybe a sodium, but it may be NaK, which is sodium potassium.
I see.
But that's in a tiny little heat pipe, and that's what moves the heat. And then you have the supercritical CO2 to turn that into as a working fluid in the secondary system. But it is a metal alloy fuel, which is very similar. I mean, the fuel for the Oklo reactor is almost identical to what was used in the EBR-2, the Experimental Breeder Reactor number 2, which operated at the Idaho National Laboratory for 30 years and supplied 25, 30 megawatts of electricity to the Idaho National Lab from 1964 to 1994. And so it's a very well proven, they have all kinds of operating history. They mined a lot of information from the national labs. And that was, again, part of the way that they accelerated their program so much is they're using a fully certified fuel design and fully characterized fuel design.
For a reactor that's already been built, tested, and operated.
Right.
Yeah.
Now the Molten Salt guys have a lot of, I mean, they have, Molten Salt is a fascinating topic, but there's really only been 2 molten salt reactors ever operated anywhere.
And now we're talking about terrestrial. We're switching back
Terrestrial and Thorcon
are
both molten salt. And there's another company, the UK company called Moltex, which has an interesting version of molten salt. They call their stable salt reactor. And that will be, I talk about that because I am focusing on North America today.
Sure.
Because it is a complex topic and we don't have time to cover the whole world.
Right.
But Moltex is got a North American project in New Brunswick, Canada.
Gotcha. And Thorcon is an American company looking at a thorium-based reactor, right?
Well, Thorcon does refer to thorium, but their molten salt reactor is sort of ambivalent to which actinide you use in it.
Okay.
They say that it will eventually be fed with some thorium after the reactor has been critical for a while. It can be used as a additional fuel, but they know that right now the cheap and easy actinide that's available commercially is uranium, and uranium is going to be in their use. There's low enriched or medium enriched, high assay, low enriched uranium. So
right.
But Thorcon, it's an American company, but they plan on building their first units in shipyards, perhaps in South Korea, and then deploying their units, which are basically a floating plant, not propelled, but a floating barge that would go and be moored into a port, probably in Indonesia as their initial customer base. Indonesia, with all of its island has an interesting power demand challenge, and they've been working with Thorcon for a while. But the Thorcon reactor has a lot of similarities to the terrestrial energy reactor. I think if you trace their histories, so there was a time when the two groups worked together very closely, and they chose some different technology and chose some different paths. But there's a lot of similarities in the reactor and
But the
design.
Thorcon reactor is substantially bigger, isn't it? Is it 500 megawatts? Am I remembering right?
It's the first one will be 500 megawatts, but it's sized to be 1,000 megawatts.
And these would be and effectively power ships that would
and
that would be very similar to, well, power ships are common, and I've seen them myself. I saw them in Lebanon. They've been deployed all over the world, but usually run on heavy fuel oil.
There's only one nuclear power ship right now.
Right, that's the one, the Rosatom.
Academic Lomsonov.
Right, and it's now in Siberia in PVEC, right? The Rosatom project, right? Yeah,
that's
and
correct.
Old, well, you know about this because they use submarine engines on it, right? Where
well, icebreaker engines.
Icebreaker engines.
So okay. it's a skimmer plant. Sorry, it's old Navy term.
Oh, okay,
skimmers.
gotcha. Right.
But no, it's a KLT-40. That's not even their newest icebreaker engine. That plant was designed maybe a dozen years ago, so they used the KLT-40. They've got a new one called the RITM 200, I believe, and their next floating plant will be upgraded with that, and their new icebreakers are using that.
I see.
So coming back to North America, so
sure.
There's some molten salt, there's some interesting technologies. There is some science and engineering that has to be done to prove out the assumptions that are being made, and there's a lot of work being done on molten salt stuff. They're a little bit longer before they're commercial.
Sure.
There's two advanced reactor demonstration projects that were recently awarded as part of the Advanced Reactor Demonstration Program from the DOE. Each of these two projects were given an initial $80 million award for design and engineering and licensing for their first year. It's a public-private partnership. One of them is the X Energy XE100, which is an 80 megawatt high temperature gas cooled reactor with a pebble bed reactor. And each of those 80 megawatt modules will have its own Rankine cycle steam turbine associated with it. The project that they're building for the DOE cost share is going to be a 4-unit plant. So it'll have a total of 320 megawatts. And I spoke to the guy in charge of that project for my podcast. I spoke to him yesterday, and he's pretty certain that they have identified the path that is going to allow them to have their first unit connected to the grid by 2027, as promised as part of this Advanced Reactor Demonstration Program. It initially conceived as a 5 to 7 year period. Of course, when the government says 5 to 7 years, they start the clock when they start talking about it. They really shouldn't start the clock until they actually start money flowing. That's my opinion, but the clock is already running. But X Energy's been working on their design since they were formed in 2009. They have a whole bunch of folks that came out of South Africa from the high temperature pebble bed modular reactor project, the PBMR project. And so they've got a fairly mature design. They're working on the detailed design work now. They're working on their design application. But they've also chosen a site which has already been certified as a nuclear power plant site. They're going to Washington, Eastern Washington, to what was initially part of the Washington Public Power System build out. You might remember that as the Whoops project, which was one of the largest bond issue defaults ever. They were trying to build 4 nuclear power plants at the same time, and some of them got started and abandoned. One of the sites, the WNP1, has a lot of infrastructure that was already built. The plant was never built, but the cooling water intakes, the pump house, a bunch of other stuff was there. And the site has already been evaluated by the NRC for a nuclear power plant. So they believe that choosing that site is also going to give them some acceleration in their project. And they're partnering with Energy Northwest, which is the operator of the Columbia Generating Station out in Washington.
Sure.
Now go ahead.
Well, I was just going to say, so now we've gone through now, I've lost count, half a dozen or so different companies, different reactor designs, and all of them, well, with the exception of the AP1000, all of them are substantially smaller than the 1,000 megawatts. But let's talk about the challenges, because this is where, when I look at this, and I'm adamantly pro-nuclear, you know, we're going to be serious about reducing emissions. We have to have big increments of new nuclear come into the marketplace. There's no, I mean, the world's top climate scientists have said this. The International Energy Agency has said this. I mean, it just stands to reason. I mean, this is not a difficult thing to understand. But the U.S. market is hard, and we're not going to forget the Chinese, forget the Russians, forget what's going on in India, Turkey. We won't talk about that. We don't have enough time. But you have a very, if I can just run through the issues, you have an electricity market that isn't growing. Electric demand in the U.S. has been flat for 15 years, since 2005. You have a very diffused ownership system in the United States, 3,000 different electricity providers and 800, 900 different cooperatives. You have publicly owned utilities like here in Austin with Austin Energy. You have the investor-owned utilities like Exelon and NextEra and Duke. And then you have the government power agencies, Bonneville Power, Tennessee Valley Authority. I mean, it's a very diffused marketplace. And there's no carbon tax, and further, you have still a lot of I was going to say animosity, but it's opposition that would include some of the biggest environmental groups in America, including the Sierra Club and including the Natural Resources Defense Council, who worked very hard to close the last remaining plant, or get the last remaining plant in California, Diablo Canyon, closed. So I can see a lot of obstacles to getting any new nuclear deployed. Where is the consumer pull, or where is the buyer pull going to come from to get these units deployed, given this landscape? And if I've missed any of the the obstacles, list them. But
no, there definitely is obstacles, and I've been watching this industry carefully watching it since about 1995, and have seen the nuclear renaissance not yet arrive. I do remind people that, oh, by the way, if you look for when the real renaissance started and do a search, you find that there's about a 50-year period where people really weren't sure whether the renaissance was actually in progress or not yet or not. And then it lasted for 300 years after that 50-year period, where the start date is still in play. So, we've been only in the nuclear renaissance for 15 or 20 years. So we still got a ways to go before we can say that it's really here. But anyway.
And when you
there's
say
obstacles, but
when I'm saying, so I want to just follow up on that quickly, because it's, when you look back at the history of atomic energy, nuclear energy in the United States, it's clear that the vast majority of these plants, including the ones here in Texas, Comanche Peak, South Texas Project, or Indian Point in New York, were built in the 50s, 60s, 70s, and now South Texas Project didn't switch on until the early 90s. But that was a time period when electric demand was growing, and growing pretty rapidly every year, reliably. And that's not the case anymore. So, well, I just wanted to throw that in as one other part of this kind of big picture story, because I think, yeah, the Renaissance may take a while. But anyway, so back to my question. I didn't have you on the podcast for me to talk.
It's all right.
But what's going to drive the adoption? Who are going to be the ones that adopt these, not in the 10 and 20 megawatt segments, but at the 100 megawatt, gigawatt scale? Where is this going to go, and why?
Well, there are a number of utilities who still have an awful lot of old coal plants. Yes, the power demand isn't growing very fast, but it's not shrinking either, except, I mean, there's some variations with current situations, but the power demand is pretty steady. And there are things that are going to be making it grow maybe a little faster as time goes on. We're really taking a much bigger look and much bigger emphasis on electric vehicles, for example. Something's got to power those vehicles, and it's not going to be the solar powering the vehicles if people want to charge at night when they come home after work.
Right.
Solar's not going to do it. So there are some other places. People are talking about, and you've talked about this on your podcast. You know, there's a lot of pressure to electrify heating,
right,
and move away from natural gas heating, and electrify stoves and ovens to move away from burning natural gas inside your house.
right.
That power demand's got to come from that new power has to come from somewhere. If we're shutting down old nuclear plants, and many times we're shutting them down for what are claimed to be economic reasons, but in reality, the plants are not making money in certain locations in the grid because the certain locations in the grid have constraints on delivering the power. I mean, nuclear plant costs have not increased. Nuclear plant costs have actually dropped in the last dozen years. They generate very affordably priced electricity, cost roughly in the $25 to $30 a megawatt hour range. But that's not competitive if you've got a whole bunch of Midwestern windmills congesting your access to the grid.
And,
you know,
or driving the price of wholesale electricity to zero or below zero.
Well, once it goes, I mean, it's a spectrum, right? So if the wholesale price of electricity is very low, that's a revenue problem. Even if it's not zero or negative, it's still a problem because you're not generating enough to pay your average costs. And over the course of a year, having average prices of electricity very low makes it so that your revenue for some plants is low enough for the owners to say, why bother? I mean, you can't operate plants for free. You know, you got to pay. It's not only do you have to pay salaries, but the management has to say there's some return coming from my shareholder investments. And if they get to the point where they're making no return, they start to say, you know, this is a lot of trouble, a lot of potential liability. You know, why don't we shut down this plant and get rid of this liability? And oh, by the way, when a big electric company shuts down a plant, they're doing exactly the same thing that OPEC does when they get together at a periodic meeting and impose a reduction in production to drive up prices, right? They're doing exactly the same thing. They are reducing an excess supply, which will eventually lead to higher prices
and tighten
for the rest of their units.
And tighten the market.
Well, yeah. I mean, if you're a company that owns 25 large generating plants and they're all selling at low prices, close 2 or 3 of the plants, and the prices will go back to a profitable level for all the rest of your facilities.
So,
all right. So
go ahead. Sorry.
In places where there's a lot of coal, the utilities are under a lot of pressure to clean up their grid. Even if we don't have a carbon price, and I personally believe that people who dismiss the idea of a carbon price are being short-sighted. There's a lot of support, even from major oil companies, for putting a predictable price on carbon. It allows you to do a lot better planning for the future and a lot better investment planning if you know there is a price on carbon. And I personally am a believer in the carbon fee and dividend program that the Citizens Climate Lobby and James Hansen advocate. But so there may be a carbon price, but even if without a carbon price, there's pressure to reduce carbon. So that's one issue. Some of these coal plants have to be replaced by something because they're 55, 60, sometimes 70 years old and still generating electricity. You know, and Some of those older plants, by the way, are
right. But rather than have them run on natural gas, which is really what's been happening in nearly every instance, that production is being replaced by gas-fired power plants. You're saying those coal plants should be replaced by nuclear plants, but
well, in some cases, they really. I mean, there've been some. There's a lot of market shift from coal to natural gas in places where both of them were reasonably well available in a reasonable distance. But you talk about transmission constraints and pipeline constraints. In places where there's really heavy coal and there hasn't been any natural gas, it's hard to replace those coal plants with gas because there isn't any gas available.
Right.
Anywhere within the several hundred miles to
Right.
get to Indiana or Kentucky
and the climate activists are definitely going to fight any new gas pipeline that would allow.
So that's an opportunity. If nukes can get their ducks in a row and produce plants that are on time and within a predictable budget, the nuclear, a well-managed nuclear project can come in at a competitive price and be able to compete against natural gas, particularly in a place where people aren't real sure about what the future natural gas prices are going to be.
Sure.
So
well,
that's
then let me
put an opportunity.
So then let me put you on the spot then. So what reactor, what company, and where? You mentioned AP1000s in the Southeast. What other?
Well, we got these.
Give me your best estimate.
Well, these two demonstration projects. I didn't talk about the second one. The second one is called the Natrium Reactor. It's a project. It's a partnership between TerraPower and General Electric Hitachi, a liquid metal cooled reactor. And the interesting twist on this is that the Natrium project has a large molten salt buffer between the reactor and the steam plant. And the molten salt buffer is going to allow it to be a much more flexible plant and spool up to have an output of, say, 500 megawatts for a short period of time, even though the reactor is just a steady 320 megawatt electric or 320 megawatt power plant, because it'll be able to store some excess thermal energy, and when the demand for electricity goes up, they can take it out of the molten salt. They can also dial back and store more heat in the molten salt if they're operating on a grid that's got a lot of wind or solar on it. So it's designed to be more flexible.
And to interrupt, TerraPower is one of the companies backed by Bill Gates, right? Based in the Seattle area. And they were, I'll just mention it because I think this was one of the things that's really interesting and maybe has been a problem or has emerged as a problem. TerraPower was working with the Chinese in China. And then with the deterioration in relationship between the U.S. and China, they had to pull back, right?
Well, it's a problem if you're Chinese, but if you're American and you prefer things to be done in the U.S., maybe it's an opportunity.
Okay.
Because they've had to figure out how to do business and they have, rather than saying it's too hard to get a license in the U.S., now they've been forced to figure out that it's really not that hard. The Nuclear Regulatory Commission has changed rather dramatically, rather subtly over the last 5 years or so. They're led by.
Go ahead. Well, go ahead.
The NRC is led by Christine Savinicki, who has been there now for, I think, 12 years, an awful lot of experience. She's a nuclear engineer by training and just a very quiet but effective administrator. So
and that change at the NRC seems to me, given what I've seen in Washington, and there's been bipartisan legislation that's been proposed and some of it's been passed, that there has been more political support on Capitol Hill for this from both sides, which has been the critical difference, I think, because for years, as a friend of mine told me a long time ago, the problem with nuclear is you need politicians who are pro-government and pro-nuclear. The problem is the Republicans are they're pro-nuclear and anti-government, and the Democrats are anti-nuclear and pro-government, right? But there seems to be a growing, Cory Booker is one of them, Lisa Murkowski, there's
Sheldon Whitehouse,
a significant number of people who are saying, no, we're going to be serious about this American development and American products and American exports, all these things, and this is positive. So there seems to be that. But now, so I'm putting you on the spot again. We talked about a lot of different things, a lot of different technologies. And we know that NuScale has a home at Idaho National Labs. But do you think that will be the first reactor then that starts actually feeding juice into the grid? Which one's going to be the first to really hook up and start pumping out the juice?
Well, 2027 is going to be an interesting year because there's XE100, the Natrium, and NuScale are all saying that that's their year where they're going to be producing electricity.
Gotcha.
In 2027. Now, I believe there's a dark horse in that race, maybe BWRX 300, and an interesting site is the Clinch River site down in the Tennessee Valley Authority area. Clinch River has got a site license already. TVA got the early site license, ESP, early site permit. That's right, ESP for Clinch River a couple of years ago, and they have it with a boundary, an envelope for a variety of small reactors. The BWX 300 fits right inside that envelope. A NuScale reactor fits inside that envelope. These XE100s fit in there. So I think there's going to be something done at Clinch River as well. And again, they're probably going to be at the 2026, 2027 timeframe for that. There is
so I just have to interject because I was in Idaho Falls 3 or 4 years ago speaking at a nuclear conference, and I saw the NuScale guys there, and I said, okay, blue sky for me. What's the best scenario when 2024. So I had to throw that in there, but I understand why it takes time, and I'm not taking shots at NuScale here because I wish them all well, but I just.
Well, I think Oklo is going to be operating by 2025.
Oh, you do? So then,
yeah.
Okay, so they're going to jump the queue here, you think?
It's a small reactor. It's pretty easy to build.
And the capital requirements won't be nearly as high.
Yeah, and they don't have they have venture funding. They don't have a very long corporate decision process as to whether they're going to go forward or invest or whatever. And their plant's not going to cost all that much. I can't remember. I had the number, but I don't have it right now.
Right.
It's tens of millions of dollars to build
the first of a kind.
Yep.
Yeah, and they're backed by some of their backing comes from an Austin-based company or Austin-based venture firm, Trusted Ventures. So, which is a guy named Sal Anchuri's based here in Austin. Okay, so
and maybe I'll take this opportunity to mention that besides being a blogger and a podcaster, I've recently become a venture capitalist.
Oh, really?
Yeah, about 2 years ago, I joined an organization that is now called Nucleation Capital, and we're going to be investing in advanced reactors and carbon sequestration, carbon utilization projects.
Oh, cool. Okay. So, and where are they based? Nucleation Capital, where are they based?
Menlo Park.
Uh-huh.
Silicon Valley folks.
Gotcha. And they need your experience in this area.
I'm a partner. So
got it. Cool. So let's talk about then the
there's some really exciting stuff happening. So that's why I'm doing this.
Sure. Well, so let's talk about the existing fleet, because you mentioned the operating costs and companies that have generation units looking to close some of them. And we've seen Exelon make that announcement, in fact, in Illinois with a couple of their plants there. Go ahead.
I mentioned plants that are in locations where they're got a whole bunch of windmills as their neighbors, that whenever the wind starts blowing hard, they fill up the transmission lines. And so they're subject to congestion pricing.
Uh-huh.
Even though they were there first, they have to pay the congestion pricing, which makes those plants uneconomical over, at where they are. They're Byron and Braidwood.
Dresden
and Byron.
I think that's right. It's been a couple months since.
But if you look at the map, they're the furthest west plants, and they're right in the wind belt, where there's, you're in West Texas, so you see windmills all over the place, but they're all the way up into Illinois. And
Sure. So should they be getting ZECs? I mean, or are you in favor? I mean, I say it as kind of a joke, but I mean it seriously. Exelon is a $35 billion a year company, and they're saying, well, we need to make more money on this. And it's difficult sale to say, oh, we need to have a bake sale for Exelon. I mean, do you think those plants should get additional consideration from ratepayers? And if so, how do you make that argument in a political setting?
Well, it's hard. I if you look on my blog post, you look for the word unfriend, you'll see that I wrote a post quite a while ago, unfriending Exelon.
Uh-huh.
I agree with you. It's hard to justify having a bake sale for a big profitable company. I do understand that those units are difficult when they're having to pay congestion pricing. And my preference as a taxpayer is that we should save money by stopping paying zero emission or wind energy tax credits, investment tax credits, and production tax credits. We should stop giving those even to projects that are building in areas where they're already an oversupply. I mean, I understand the need to decarbonize, and I understand the importance of building new emission-free sources and encouraging that. But it doesn't make sense for the carbon production tax credit or the investment tax credit for solar to be the same no matter where you're building, and you're incentivizing people to overproduce even in places where the grid is already congested. And that's what's happened.
And the congestion problem, I mean, I was talked to a solar developer here in Austin in February, and he was saying transmission's our biggest problem. We can't build, we can't get the transmission built. But
well, what did you guys do in Texas when you had too much wind in West Texas?
Well, they built.
You spent $10 billion
and rate-based all of it, and they charged it all to the ratepayers too. The CREZ lines are being paid by ratepayers. The cost of all that is being paid by ratepayers. So yeah, there's this.
So it doesn't make sense to me to incentivize people and then have to pay the people that got damaged by the incentives. So it's all coming from the taxpayers and ratepayers.
I completely agree, and therein lies one of the problems with the whole ZEC argument, the zero emission credits. That so now to cure the market distortion that's been caused in part by the renewables, we're going to implement another set of subsidies to counteract the subsidies we put in the first place.
Which is why I'm a carbon tax fan. I think a fee on carbon is a much more legitimate and economically sound answer to incentivizing or discouraging carbon-based fuels, while then allowing people to say, well, I can compete. I do have some initial costs to cover. Give me some way to make a little extra money, and avoiding carbon taxes was one way to do it.
So is that one of the keys then to helping nuclear develop then in the U.S.? Is that essential?
If there was a reasonable carbon tax, it doesn't have to be huge, but a reasonable carbon tax of say $30 to $40 a ton would be enough to make it so that early stage, not first of a kind, but early stage in the development, nuclear could compete. Once they build a few of those, then nuclear is going to be gaining some momentum. And the way to drive down costs is no mystery. It works in flat screen televisions, it works in computers, it works in LED lighting, it works in solar, it works in wind. And the answer is repetition.
Sure.
Okay. Get some experience, build more, and you really do drive down the cost.
Right.
And now eventually there's going to be a shakeout in the nuclear business. We've talked about a lot of different technologies. They don't have all common features, and there's different supply chains, but some of them, NuScale and X300 and Ap1000 are using supply chains that already have some momentum and some existence and some, history. There are some other commonalities. The XE100 is using standard steam plants, so that they don't have a huge uh, uh, supply chain issue. But yeah, there's going to be some narrowing down. But for right now, you know, there are features of nuclear that make it have the possibility of competing. But you can't do what Westinghouse did. You can't go to a customer with an incomplete design and have the customer pay all the startup costs and the first of a kind costs, and you make, if you have issues on your first plant, and your first plant in 30 years is a gigantic project, it's no surprise that you have trouble.
Right.
You really do want to play high school football, then college football, then get to the pros. You don't want to jump, no matter
right.
how good you think you are.
Right. So that these technologies really need to be mature and fully, fully vetted. And I think that's one of the interesting things about the Oklo design is that if you can minimize that upfront capital cost, then that's a big hurdle.
Oklo's not interested in selling their reactors.
Well, that was one of the other things that was interesting to me. They want to design them, build them, and operate them, right? Which is different from GE's not going to be the operator and the owner. They're going to sell it to somebody else.
Well, there's a historical reason why GE and Westinghouse went that way. Up until the Energy Policy Act of 2005, it was illegal for major vending companies to be power utility companies.
Huh. Okay. I didn't know that.
Yeah. It was part of the PERPA. I can't remember all the acronyms involved, but if you were a GE or a Westinghouse, you couldn't own and operate power generation plants, just like in the media business, there's certain separations, but that was a separation. It was a way to.
May have been the legacy of the Public Utility Holding Company Act of 1925,
exactly.
Right? The breakup of the big utilities. So let me move forward. We've been talking for a while.
An owner operator is an interesting model. That's what the Navy's model was.
Right. Well,
we owned it. We operated it. We trained our operators. We took responsibility for the whole thing, with some contractor support. But
right. And is that, well, you beat me to the punch on one of the questions I had, because the Navy is arguably the best nuclear operator in the world, and they've never had any significant accidents. The Russians have, of course, but why is that? Why is the Navy been so good at this for now 70 some odd years? Is that we're in that neighborhood, right?
Well, since Rickover started putting things together in 1949.
Okay. So
for the Naval Reactors program.
Right about 70 years, yeah.
Yeah, that's a long time ago. There's an awful lot of history. There's a book called The Rickover Effect by Ted Rockwell, which helps explain part of the whole program that Admiral Rickover put together. He really had some philosophies that were dramatically important for building a highly technical, responsible organization with clear lines of responsibility and accountability, an important emphasis on training, selecting people. I mean, he interviewed every single officer that came into the program. And by the way, that tradition has continued. All the people that have held the Naval Reactors job, the one that Rickover held, personally interview every officer that comes into the program. There's a very lengthy set of things that the Navy has done right. Now, my personal belief is Admiral Rickover stayed in the job way too long. I mean, he didn't leave the office voluntarily, even at 82 years old. He had to be pushed out by John Lehman. And, for some reason, although by that time, every single person in the program had been selected by him and trained by him.
Huh.
He couldn't find an admiral that he could trust to turn over to. So he wanted to keep holding under the reins.
And that would be John Lehman. That was in the Reagan administration, right?
Yep.
Is that right?
Yeah, 1983 or 82 was
82 or 83. Yeah.
Yeah. I was in the second to last class to ever have a real Rickover interview, although they're still called Rickover interviews, even though he's not there anymore. Yes, he passed away in 1986, I think.
Right.
But so that program has all kinds of value, and I sometimes anger some of my compatriots in the program because I keep saying, guys, I understand your importance on national security and all that stuff, but you really could have a much bigger impact if you opened your kimono a little bit. And they've got history, they've got material science and operating experience and training manuals and operating manuals and all kinds of stuff. They're just fantastic materials, but we say that it's all classified.
Uh-huh.
But I can tell you about them. I can't tell you any details, but I can tell you about them. And I really believe that one of the things that if the U.S. really wanted to start being an important player in nuclear again, one of the things we should do is, with some consideration, there are a few things they should keep secret, but declassify almost everything the Navy does. They build engines
on the nuclear front. Yeah.
The nuclear part.
Right.
We convert an awful lot of military jet engines into commercial use. There's an awful lot of transfer between the military and commercial in the jet engine world.
Sure.
But in the nuclear world, there's almost no transfer of detailed information, and certainly no shared factories. They keep completely separate. The fuels are different. And part of that is the companies that supply the Navy. There's not very many of them. They're very comfortable in their very tight world, they're very
having a
captive audience. Yeah,
right. And that's Babcock and Wilcox, is that right? That's one of the suppliers. Is that
Bechtel's a primary supplier, but B&W supplies all the fuel.
Right.
Either them directly or through nuclear fuel services. But
right.
Yeah.
So let me ask you about that. So is that classified? Because the von Steuben you mentioned the S5W reactor. What was the output of that reactor in electric output?
Well, it's a propulsion reactor, so I could tell you what it was in shaft horsepower.
Okay. What was it? But you can't tell me the megawatts electric. Is that the classified part of it?
Oh, it didn't have a generator.
Oh,
it
okay.
had steam turbines. It had some generators. Obviously we had some electrical power in the system.
For hotel.
About 4
right.
megawatts worth of hotel loads. But the propulsion plant was, connected to reduction gears and drove a shaft. So it really wasn't. And I probably could, go back and reverse calculate or whatever. It was a 15,000 shaft horsepower.
Uh-huh. Gotcha. Okay. Yeah. Well, I can do the math on
Yeah.
that one. That's
okay.
Yeah. Okay. But those numbers are still, for nuclear Navy guys, those numbers are still considered classified in terms of the scale.
There hasn't been an S5W plant operating in a long time. So if somebody's going to come get me, they're going to come get me. Actually, I shouldn't say that. That's probably not true. There are 2 S5W plants still in operation as training. We call them prototypes. Obviously, they're not prototypical of anything. They're training plants in their moored training ships in the Cooper River in Charleston, South Carolina.
Gotcha. Well, so let me jump. There was one question I wanted to just jump back to, because in terms of these other hurdles to deployment, and then I just have a couple more things, and then we'll jump off here. But I remember I didn't include this in my last book, but there are 14 states. I just looked this up again that have restrictions on the construction of new nuclear plants, and 6 of those, I believe, are regulation that prevent new reactors from being built until there's essentially a federal waste repository. So that's another big hurdle in terms of siting, because then you're going to have state legislatures involved and either reverse existing regulations or pass new ones. But that's a long intro to this question then. So we still don't have the waste repository yet. And we have the waste isolation pilot project in New Mexico that handles radioactive waste, but only from the military. Why couldn't we just put civilian stuff there too? I mean, why is this? That's one question. And then the second is, why is this problem? Why can't we resolve once and for all this issue of nuclear waste? There's still fights over a new Holtec's new proposed facility in New Mexico. Why can't we solve this problem?
We have solved it. I mean, here's the real answer to the waste issue, is that we've been safely storing nuclear waste for 70 years. Not a single person anywhere in the world has ever been harmed by exposure to nuclear waste. We know how to store and handle it. We can store it for a long time. And if the containers start to deteriorate, well, you unload them and put them in a new container, or you repair the container. You do the same thing you do for any other piece of infrastructure you have. You don't just assume that it's going to last forever. You build it, you monitor it, you inspect it, you repair it if necessary, you move forward. So it's not a problem, and it's not even a big size issue. I mean, the dry storage casks that are stored on existing operating sites are not a big issue. In some places, you can't even find the waste storage facilities on the site. They get lost in the shuffle. They're pretty small. They're pretty contained. Now, once you get dry storage containers, yeah, you got a couple of some big ugly casks, and it may be a good sized parking lot, but
Sure.
It's not a big issue.
Right.
But the problem is that the U.S. government has declared that it is going to be the final owner of the material. And it forced all the utilities to sign contracts agreeing that the government would take the final delivery. And
this
by
is
doing that,
the Nuclear Waste Policy Act of 1984, is that right?
yeah. And
Yeah.
by doing that, and of course, the only reason the utilities came to the table was that their previous plan for waste, which was to recycle the material and use it productively, they had already a plant that was almost ready to start running in Barnwell, South Carolina, when the president signed a piece of paper that said no.
Jimmy Carter
said,
1978, a nuclear Navy guy. What did I get wrong? He wasn't a nuclear Navy guy.
Jimmy Carter, and you can look this up very easily in a history book. He left the Navy in October of 1953 and went back to Plains, Georgia to farm peanuts. His father had passed away in the summer of 1953. The first U.S. nuclear submarine went to sea on July 17th, 1955.
Okay, Navy guy.
So he was a Navy guy. He was a submariner, and he was selected to be a nuclear Navy guy. He started nuclear power school, which is the very first stage of training. He started that in March of 1953. His father passed away
shortly thereafter. Yeah,
his father passed away in the summertime while he was still at Navy Nuclear Power School. And now this was a very special program. He'd been personally interviewed by Admiral Rickover. He had made a commitment to the Navy to do this special program, but they let him go. Now, I don't know the reason why they let him go, but they did. Now, some people say it's because his brother was incapable of running the family farm after his father died, and Jimmy had to go back and do that. Whatever. But he got let out of a program. I happened to have, at one point in my Navy career, was a good friend with a guy whose wife was Rickover's personnel officer, and she knew Jimmy Carter, and they didn't let the door slam on his bottom on his way out. And of course, Rickover never said anything bad about Carter, because by the time he heard the word Jimmy Carter again, he was the president of the United States.
Right.
And Rickover was still, operating reactors for the Navy. And hey, if you're 4-star Navy guy, you're not going to pick a fight with the president. Come on.
Sure.
The president wants to say he admires you. Yes, you're all right. That's a good thing for your program.
Sure. Gotcha.
So,
But that's,
anyway,
I'm interested. That's
so
interesting.
yes.
Because
So
there's some
going back, the
fairly,
waste issue is,
yeah, go ahead.
waste issue has been inflated, and there I can show you documents where people who are opposed to nuclear have gotten together and strategized about how to use the waste issue to constrain the industry.
Oh, well, I think there's no question about that.
I call
mean,
it the constipation strategy. And it's never going to be solved politically. Somebody told me that all it takes is one senator to table anything to do with getting a repository cited. And if that's true, if all you need is one senator to stop it, you're never going to get an agreement. I think the industry's got to say, we have it, guys. We know what to do. The waste is safely stored. You guys need to stop worrying about it. But of course, as long as the industry feels that the government owes them money because they failed to deliver on a contract, the industry is not going to say, well, we've got it, because they want to get their money.
Right.
And so,
but the problem is that the taxpayers are paying for this many times, right? They paid to build Yucca Mountain. They're paying to just maintain it, I guess, while it's still being, litigated ad infinitum.
Yucca Mountain never got built.
Well, okay, they dug a hole anyway, or they
dug one hole for science. They never built the repository.
Oh, okay, fair enough. But there were billions spent, nevertheless.
Oh, absolutely.
And now the government has had to pay these lawsuits under the government's failure under the Nuclear Waste Policy Act. But anyway, I don't want to spend too much more time on the waste part of it but it's just one of these other sticking points that's been a sticking point for decades. And with these states, many of them now with these regulations, it further constrains the places where they might be deployed that are going to take more legislative action.
They certainly aren't going to be the first customers.
There you go. That's well put. Okay, so
if they see their neighbors doing well because they're accepting nuclear, maybe they'll change their minds.
Right. So why do you care so much about this? I mean, you've had a long career in this, but you've really dedicated most of your life to this. Why do you care so much about
it? My wife asked me the same question. Lots. It's hard to say. To me, first of all, I have lived inside a sealed submarine powered by this magical power source. I mean, the fuel on board my submarine weighed approximately the same as what I weigh, but it powered a 9,000-ton submarine at speeds almost unimaginable underwater, gave us all the lighting and refrigeration and electricity we needed for whatever games we wanted to play or movies we wanted to watch, or it made fresh air out of water by splitting hydrogen and oxygen. We made for all the fresh water we needed. And it did this for 14 years without ever being replaced, that same mass of fuel. Now, I know that there are so many problems in the world that could be addressed and mitigated, not necessarily completely eliminated or solved, but made a lot easier if we recognized that we have this power source that's a natural part of our Earth environment. Uranium is abundant, and thorium is 4 times as abundant. We've got an inexhaustible supply of this emission-free power, the power to do anything you want to do. I mean, if you want to power a super yacht with a nuclear engine, you could go wherever you wanted. Just be like having a very fast sailboat, but you wouldn't even need to plug in the shore power.
Right.
You have, it's just incredible to me that, and when I finished my engineer career, or engineer tour, I should say, not career, I went to the Naval Academy on shore duty, and I had a lot of free time, and I spent months reading books we had this huge section of books about nuclear energy. We had a good section of books on the opposition to nuclear energy. And I kept trying to figure out why. Why did people who said they were concerned about clean air and clean water, why didn't they like this power source? And eventually I came to the conclusion that an awful lot of the opposition to nuclear was stimulated and funded by people who wanted to sell other kinds of energy. It was a competitive thing. This magical power source was like having Shaquille O'Neal try to play basketball on the kindergarten court. I mean, think about that. And of course, he could just drop the ball into the little basket that they have on the kindergarten court, because that's what, people go to all kinds of trouble to try to come up with ways to clean up the emissions from a coal plant, the scrubbers and the chemistry and the bag houses and all kinds of stuff. And, I say, clean? I ran with a thing inside my submarine.
So just to follow up on that, so you think that the opposition, even today, is still being funded by, when I'm completing your thought here, I believe, is from the hydrocarbon sector, from people selling coal, oil, and natural gas?
I call it the hydrocarbon economy interests. I mean, we have.
So the Sierra Club is doing the bidding of Exxon?
Either purposely or accidentally. But by the way, the Sierra Club did accept, $25 million from a fracker
from Chesapeake Energy, right,
to go beyond coal. But of course, money's fungible. How do I know what Sierra Club spent the $25 million on? And of course, that's just one little, I call it the little blips that you see when people are really trying to hide stuff. Every once in a while, you get a hint of stuff. Friends of the Earth was a breakaway. When David Brower broke away from the Sierra Club to form Friends of the Earth, he did it, and he purposely formed an anti-nuclear organization, because at that time, the Sierra Club still had a campaign of atoms, not dams, going on. He broke away from the Sierra Club to fund this anti-nuclear organization. The guy who wrote the first check for $200,000 in 1969 was Robert Anderson, who was the CEO of ARCO. That's just another little hint. Right. And in many cases, once you stimulate this and you establish a propaganda, an idea, you don't have to keep funding it. You get the momentum going, and then you stop. People who have lots of money often figure out ways to get the government to pay for for their things. But the Rockefeller Foundation funded the first 10 years worth of effort by the National Academy of Sciences to determine what the health effects of low-level radiation are. And they found a guy who would adamant that the effective low-level radiation was measurable all the way down to zero, not just slight, but all the way down to zero. And there was no safe dose. Of course, everybody else, except for this guy, who ended up getting a Nobel Prize and leading the National Academy of Sciences and committee evaluation. But yeah, yes, there is
a legacy of the anti-nuclear movement comes out of the hydrocarbon sector.
Well, there was a time, there was an organization that is lost in history to most people called the National Coal Policy Commission. And it was a lobby group founded in about 1956. And it was an interesting group because it was comprised of unions, railroads, coal mining equipment companies, and coal mine owners. Now,
all of whom saw the nuclear business as an existential threat, to use that. Well, now that term that we hear all the time.
Yeah, and I've got a book on my shelf that's got all this history. There's times when the coal industry was the only people testifying against nuclear. I mean, it even talks about the coal boys going to commission meetings and saying, hey, we got to stop the subsidies. This Price-Anderson Act is an unfair subsidy, and you're giving them insurance at below market rates, and
we
you've
still
got
hear
to
that.
stop this.
And we still hear that today.
You got to stop calling these reactor projects demonstrations, because they must be commercial because the utility's buying them. You got to stop giving them low-cost fuel, all this stuff. And by the end of the 1970s, I even got a little article from the New York Times, like an end of the decade thing, and it talked about how the coal guys had now finally convinced the youth movement to take over against nuclear.
And then you add in the issue of atomic weapons, nuclear weapons, and you get a very convenient kind of anti-nuclear, anti-war peace movement that is all conflated into one. Well,
especially once you find out that the guy who was one of the major leaders of the whole atomic atmospheric testing program, he was a driver of the Atomic Energy Commission's focus for the first 8 years on bombs and nothing on power. And he was the guy who pushed for the H-bomb. And he was also the guy that fired Robert Oppenheimer. And oh, by the way, then he sabotaged the nuclear industry or saddled us for life by saying that atomic energy will eventually be too cheap to meter. Lewis Strauss did all those things. He was a Wall Street banker and an advisor to the Rockefeller family.
Huh. Well, that's
although he's called Admiral Strauss.
Right. Well, that's history. That's history that I didn't know, and is interesting. So, Rod, we've been talking for a while here, and I've taken more of your time than I anticipated. So, just two more questions, if you don't mind. So, what are you reading now? I like to ask this question. You know, I've got several books that I'm working on, and many that I'm. You know, one of them is Meredith Angwin's new book. I interviewed her recently, Shorting the Grid, which is a really interesting book, and I know you and Meredith are friends. I'm reading a book called The Genius of Birds. What are you reading? What's on your shelf?
Well, I am reading Daniel Yergin's new book, The Map. I just finished Matt Wrigley's new book on innovation. Let's see, I've got a whole bunch of trash novels that I've got this habit of reading books that are set in Florida, South Florida, the Keys. I mean, one of my favorite authors as a young guy was the Travis McGee series of books. I don't know if you're familiar with Travis McGee, but he was a guy who retired to a houseboat in Fort Lauderdale, Florida, and he only worked when he needed to. So the books are all his adventures, the times when he took assignments to go do some work. So there's a new book series of book I'm reading with a guy who lives on a mega yacht because he had so many adventures. He wrote some screenplays that got picked up. So he lives on a mega yacht, but he still works as a volunteer deputy sheriff. He's trip wild. But like I said, these are just fantasy books of mostly set in Florida, because I'm a Floridian for life. I grew up in Southeast Florida and finally retired to Florida in 2000.
No Carl Hyacin, isn't he?
Carl Hyacin one of my favorite. But I've read all his books. I can't say I'm reading him now. I've read every book that he's ever written, and I've got a library shelf somewhere. You can see they've got a few shelves here.
Yes, I see. Yeah.
And my granddaughters come into my office and say, "Gramps, have you read all those books?" And
most of them.
Yeah. So I mean, one of my most dog-eared book is Daniel Yergin's The Prize.
Uh-huh.
I mean, that is a book that anybody who wants to understand the battle for oil, wealth, and power really needs to understand. And that book also helps you understand the importance of controlling the supply-demand balance, because the profits in the oil industry, oil and gas industry, are very much tied to whether or not there's just enough supply, too little supply, or too much supply. And the variations are very small.
Sure.
Because both of those commodities, they can be stored for a little bit, but eventually run out of tanks.
Right.
And once the tanks are full, how much is the next barrel of oil worth? Not a whole hell of a lot.
Exactly. Well, we're still going through that today because there's demand.
We've had negative price oil.
I know
during COVID. I mean, negative priced oil.
Yeah.
People paid you to take it. That's pretty incredible.
It is pretty incredible.
And of course, natural gas drops that way in the Permian Basin on a regular basis. And
sure. So last question then, Rod, and you've been very kind with your time. So what gives you hope? You've been working on these issues for a long time, and I think you could be easily discouraged because of how long it takes. And what keeps you hopeful?
Well, I'll be honest, I have been discouraged at times. I've been very discouraged. But right now, there's an incredible momentum full of very smart, younger people than me who are focused on addressing some of the world's thorniest problems. They want to provide fresh water. They want to provide clean electricity. They want to enable and lift people out of poverty by giving them access to real electricity, not a light bulb, but enough electricity so they can have water pumps and clean water flowing and, you know, all of the things that we kind of take for granted, but that enable people to have the time to do real things rather than spending their whole days carrying firewood or going to a well that, you know, because they don't have pipes and they don't have pumps and all of those things. I mean, your movie on electricity really was a huge, beautiful movie about how important that power is. And what gives me hope is I know a whole bunch of people who have a great way to supply that power in ways that won't damage the ecosystem, and in matter of fact will help us reduce human footprints by not paving whole mountainsides or fields or deserts with collectors. You know, that gives me hope, and it gives me optimism and passion for what's going to happen. And you know, there are people on both sides, all sides, because I don't like a bifurcated. I kind of think that sometimes political commentators were trained by sports journalists, where there's one side winning and one side. But there's interest in all ways, and nuclear ticks so many boxes for people. It's good jobs, it's abundant energy, it's clean air, it's clean water, it's sustainable. It can power itself and power growth for itself. You know, I can't find a place where you can power a windmill factory by windmills. You can't power a solar factory with solar because you need power that's more reliable.
Yeah.
And, you know, people say, well, we can have a multiplicity. I say, well, if you need a multiplicity, that's expensive. If you need this and this and this and this, it's expensive. So anyway, that gives me hope, gives me power. I mean, gives me optimism, makes it fun to wake up every morning. And people who follow my Twitter account will know that I wake up early every morning. I'm usually conversing with people from Europe or Australia because nobody in the U.S. is awake at that time. So
right. Well, Rod, this has been great fun for me, and I'm really glad to go through and get your views on, you know, the different companies and different reactor designs.
And I apologize to any company that I forgot to mention.
Okay.
I'm sure there are somebody out there. Rod, you forgot.
I'm sure there are. Well, my guest has been Rod Adams, the publisher of AtomicInsights.com, a podcast host as well with the Atomic Show podcast, which you can access on his website. He's also on Twitter @AtomicRod. I follow him. You should follow him. He's obviously very passionate about these things. So Rod, thanks a million for your time. This has been great fun. And to all you out there, this has been the Power Hungry Podcast. If you like it, then give us a positive rating on your Apple account or your iTunes account or wherever your favorite podcast host is. And make sure and tune in for the next issue of the next episode of the Power Hungry Podcast. And until then, I'm Robert Bryce. Thanks again for tuning in.
All right. Bye.
Thanks, Rod. Bye.